Okay, so I know this is still GP number 1A, but I wanted to add some toolbox items to this before I move on to the next one. So just some things to kind of think about. We're going to write points as ordered pairs. Write lines as equations. Increasing and decreasing intervals use X values. And let's go ahead and rewrite the slope formula down here. Y2 minus Y1 over X2 minus X1. All right, so for the next GP, we're going to use that other graph that I put on the printables page for you. Okay, so again, the first thing we want to identify is the axis of symmetry, and I'm going to go ahead and use abbreviations for this one. So axis of symmetry, we're going to say AOS. Axis of symmetry is the line that goes through our vertex, and that's going to be x equals 3. The next thing we're going to identify is the vertex. The vertex is right here. And that is the point 3, 7. Then we have, does the vertex represent a max or a min? Now in this case, our vertex happens to be the very highest point on our graph, and the very highest point would naturally be the maximum of our graph. So the next question is, what is the max or minimum value of the graph? And remember, that's that y value. So the maximum value of the graph here is 7. Now, typically speaking, here is where we would identify our x-intercepts, but notice on the graph that they're not really very nice numbers. So I'm never going to ask for you to identify the x-intercepts when they're not clearly identifiable. So we're going to leave that one off. So next we have y-intercept. The y-intercept is where a graph crosses the y-axis. That is this point here at 0, -2. Then we have the increasing and decreasing intervals. Increasing and decreasing intervals. So let's go ahead and mark on our graph with our markers and see which side's increasing and which side's decreasing. So if I move my marker from the left side of the graph to the right side of the graph, currently my graph is increasing. But remember, it's going to stop and it's going to turn around as soon as I hit that axis of symmetry. So my graph is increasing on the left side of the axis of symmetry. And then it turns around and now it's decreasing on the right side of the axis of symmetry. So reading from left to right, the left side of the graph is coming from negative infinity. So the increasing interval is negative infinity, less than x, less than or equal to, well, it stops increasing at the axis of symmetry, which is where x equals 3. And then at that point, it turns around and now it's decreasing. So our graph starts decreasing at positive 3 all the way to the right, which is positive infinity. So 3 is less than or equal to x, which is less than positive infinity. Now let's go ahead and write those intervals in interval notation as well. So for increasing, because it's not equal to at negative infinity, we use a parentheses. Negative infinity, comma, all the way to positive 3. And because it is equal to at positive 3, we use a bracket. And then the decreasing interval, it is equal to at 3, all the way to positive infinity, but not equal to infinity, so we use parentheses. So I may ask you to write one way or the other, but we're going to practice writing both if it's not specifying how to write it. Then we have the domain. The domain are all of our x values. The left side of the graph all the way to the right side. So this arrow points forever to the left. This arrow points forever to the right. So that's negative infinity, less than x, less than positive infinity. Or in interval notation, negative infinity to positive infinity with parentheses. The range, the bottom of the graph to the top of the graph. So our graph is pointing down and it goes infinitely down. So from negative infinity, less than y, less than, we have a point up here at the very top at the maximum of our graph. So less than or equal to positive 7. And then in interval notation, parentheses, because we're not equal to at negative infinity, to 7 with a bracket because it is equal to at positive 7. And then the last thing we're going to find is the average rate of change. Over the interval from 1 to 4. So find the point on our graph where x equals 1. X equals 1 right here, and that is the point 1, 3. Find the point on our graph where x equals 4, and that is the point right here at 4, 6. Now again, if I draw a line between those 2 points, that line is increasing as it goes to the right. So we should have a positive slope here. So m equals, see, x1, y1, x2, y2, 6 minus 3 divided by 4 minus 1. That's going to give us 3 over 3, which equals 1. And that is our properties of parabolas.